Hello students, today we'll continue with the same unit of data analytics, that is about descriptive statistics and probability. In this lecture we are going to study what is probability and its terminologies. We will be focusing on probability distribution also. Now, as far as probability is concerned, it can be defined as a mathematical method used for statistical analysis. Probability and statistics are interrelated term in term with respect to mathematics. Now, when it comes to probability, we all have studied probability in our school and college life. The probability is the same concept as if we are throwing a dice and we may get one possibility out of six. Since there are six numbers display, we have six faces in a dice, so there is a probability, always a probability of getting one, and same will be the probability of getting 2, 3 and 6. So if we talk about the possibility or the probability, then it would be same. We can say that for example, if we want to calculate the probability of getting 3, then we can say that probability of getting 3 is 1 by 6, because the output or the total number of cases is 6. Since we have six numbers on our dice, so total will be 6. So in short, we can define probability as desired outcome divided by total outcome. Whatever we are desiring, that comes in the numerator, and whatever is the output total is that comes in the denominator. So if we want to calculate the probability of getting 3, then it can be, we can say it, that probability of getting 3 will be 1 out of 6, because one time we will be getting 3 if we compare it with the 6. So coming on to the next term, that is terminologies in probability. We have two basic terminologies in probability: random experiment and sample space. Now, what random experiment is: an experiment or the process for which the outcome cannot be predicted with certainty. That is a experiment in which we cannot predict the outcome. It is not certain that this output, that we are going to get this output. As in case with the dice, when we throw the dice, it is not certain that we will be getting 6. There is a probability of getting 6, but there is an equal probability of getting 1 to 5 numbers. Same is the case with random experiment. Random experiment tells us it's a process in which the outcome cannot be predicted with certainty. We can just assume that it can be that we can get a desired result. Now, coming on to the sample space, then sample space is the entire possible set of outcomes of a random experiment. Like whatever possibilities are there, whatever the whole set of outcomes, whatever we are assuming, that comes in the sample space, and it is denoted by S. For example, if we are taking the same example of throwing a dice, then there can be a set of outputs. Like it, when we throw a dice, we may get 1, we may get 2, we may get 3, and till 6 we may get 6 output also. So what are the total set of outputs we can get is 1 to 6. So one number of possibilities, that is 1, 2, 3, 4, 5, 6, comes under the category of sample space. And what we need to find out, or what we are expecting, we need to find the probability of appearing 3 in this case. So when we talk about random experiment, then finding the probability of appearing 3 will be a random experiment. Whereas if we talk about the sample space for the same example, then it will be 1, 2, 3, 4, 5, 6, because we may get any 6 possibilities out of the 6 numbers. So that comes under the category of sample space. Now moving ahead with our next topic is events. Now, when we talk about probability, events also plays a major important role. But then it can be defined as one or more outcomes of an experiment. Whenever we are performing an experiment, then we may get one or more outcomes. We may get one output, or we may get more outputs. So it depends upon the case we are dealing with. So we can define event as one or more outcomes of an experiment, whatever we are performing. If we consider the same example as we took, that is the example of throwing a dice, then in that case also it will be a probability of getting 3. So in this example, it will be the events are considered as the probability of getting 3. So coming on to the types of experiment, basically we have two types of experiment: disjoint sets and non disjoint sets. Now we'll start with the basic one, that is first one, that is disjoint set. It pretty easy to understand what are disjoint set by referring the diagrams. Now when we refer this diagram, we have two balls x and y of green and blue color. Now what are disjoint sets? When we talk about disjoint sets, then disjoint sets are the sets that do not have common outcomes. That is, if any example we can take which does not have common outcome, that comes under the category of disjoint sets. For example, example is shown in which a card can be drawn from a card deck, and it can be either queen or king. Same is the case, like if I am taking out the card from a card deck, if I am picking any card, it can only be queen, or it can be queen king, or it can be one, or it can be two, any number it can be. It can't be one card can't indicate two numbers, like it can't be both king and queen. So if we are picking any one card, there is a possibility that any one could be picked, like it could be king or it could be queen. It can't be both. So this is known as disjoint set, in which common outcomes are not there. Now, when we talk about the non-disjoint sets, then as shown in the figure, there exists a common outcomes. Like in case of A and B, we have two sets A and B, and in A and B we are having a common outcome, that is A and B. That is, the common outcomes are the part which exists in both A set and which exists in B set also. So, example we can take as a student having a mark sheet, and he is getting 100 marks in maths also, and he has got 100 marks in science also. So what is common in this case? Student is common, because the same student is getting marks in maths and in science. And the other thing which is common is 100 marks, because the student is scoring 100 marks in maths also and in 100 marks in science also. So in this case both the terms are constant, that is the student and the 100. So two terms are common in this particular example. So any example or any sets in which there exists a common property between the sets are known as disjoint sets. So students, I hope I'm pretty clear with both these terms. Moving ahead towards our next important topics, which is probability distribution. Now when we talk about probability distributions, then probability distribution functions are broadly classified as probability density function, normal distribution, central limit. These are the three terms which are basically comes under the category of PDF. Now what PDF is? Probability density function is concerned with the related likelihood for a continuous random variable to take on a given value. Now what does it mean? It means that probability density function is basically indicating a range of a random variable. Like the random variable may vary between the range. So the diagram which is shown on the right hand side, it is indicating the range. The red mark is indicating the range of a random function where it can lie. So if we talk about any random function, it can lies within the portion of the red mark. So that red mark is indicating the range of a random function. So PDF is nothing but a function which basically it is indicating the range of a random function where it can take place. So PDF basically gives a probability of a variable that lies between A and B. So PDF is finding a probability of a continuous random variable over a specified range. We can, in short, we can say that PDF is nothing but it is just showing a range of a continuous random function. What range we are talking about? About the probability of its occurrence. So moving ahead with the normal distribution now. Normal distribution is also known as Gaussian distribution. The idea behind is that the data near the mean occurs more frequently than the data away from the mean. Now, what does it mean? It means that if in any particular example, the data which is near to the mean, the occurrence of that data will be more if we compare it to the data away from the mean. Now, in short term, we can say that the data around the mean can represent the whole entire data set. Now the example we can take, for example, as shown in the figure, we have compared the height of men and women. So if you can see the height of average height of women's are 60% of women are having average height, and 70% of men are having average height. So we can say that we can predict that since mean is the center of the curve, if mean is representing 60%, so 60% of women in India are of average height and 70% of men are in India are of average height. So by referring the diagram and by calculation of mean, we can calculate the normal distribution. So actually normal distribution are always centered on the average value. So whatever is the center value, that value is actually representing average value. So since in this diagram 60% of women is representing the center value, so we can say that 60% is the average height, average women's 60% of women are having the average height. So by looking at the graph, we can conclude a probability. This is known as normal distribution, in which by referring the graph and by referring the mean, we can conclude with the probability portion. Now coming on to the factors for normal distribution. Now when we talk about normal distribution, we need to know two main points or two main calculation, which are mean and standard deviation. Mean is nothing but the average measurement, as we discussed in our last slide. So mean tells us where the center of the curve goes. So it actually determines the center of the curve. So if any curve is having a small deviation, then the curve will be more heighted. And if the any curve is having a large standard deviation, then the curve will be of short height. So any mean can be calculated by just referring the center of the curve. Now when we talk about standard deviation, standard deviation is basically nothing but it is determining the height of the graph. So width of the graph determines how tall it is. Like it can be shown in the figure. It is very clear to be observed. Like in the first case, standard deviation is very small, so we are getting a heighted curve. And in the second case, standard deviation is very large, so we are getting a curve of normal height. So in this way, it depends upon the standard deviation, and according to the standard deviation, the height of the curve can be determined. Coming on to the last one, that is central limit theorem. Again, it is a very important topic in this category. When we talk about central limit theorem, it states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. So it means that when we take the whenever we are calculating the mean of samples and the mean of population, we need to calculate the mean of samples separately and mean of population separately. And if in any particular example of in any particular case, if we are calculating the mean of sample and mean of population, then it has to be similar, approximately equal or almost equal or equal to the mean of the population. That is, after the calculation, both the means of sample and the population should be same. This is known as central limit theorem, uh, in which the mean of the sample and the mean of the population comes out to be same if the sample is representing the mean, and if the mean are same, that it is indicating that that particular sample is representing the population. See, it may sometimes happen that the sample we are observing or sample we are considering is not does not belong to the population. It may happen that there may be a number of population, and the sample we are observing, it got mismatched, and we are observing a wrong sample which does not belong to our population. For example, if there are 5 population and there are 10 samples, and I'm working on sample number 5, and I'm assuming that my sample belongs to population number 1, but the fact is that my sample 5 is not of population number 1, it is of population number 2. So what we need to check is the very first criteria is we need to check whether the sample we are observing that comes under the category of the population we are zooming. So in this case, what we need to do, we need to calculate, I need to check whether the sample I am working on is of that particular population or not. So for that, what I need to do, I need to calculate the mean of the sample, and then I need to took the mean of the population. If I compare, if I found that the mean of the sample and the mean of the population are matching with each other, or they should be almost equal to, or they should be equal to, if they any of the criteria matches, that means that my sample belongs to that particular that specified population. If they are not matching, that means that sample is not under the category of that population, and I need to go through that, or I have by mistake chosen the wrong sample for survey. So in this case, we can just, by central limit theorem, we can just determine whether the mean of the samples and the population are matching or not. So students, I hope I'm clear with this point also. In our next lecture, we'll be starting with the next topic of data analytics consisting of the same unit, that is first. See you. Good day.